All right, so you're going to start hearing me count down so I can try to get this camera to sync with the screen because I had to do a little bit of editing on the last video, too much personally, because I could not get, I had to try to get my movements on the screen synced with what I was saying. So 3, 2, 1, and there we go. Okay, so now, next topic, network symbols. Okay, these are the things you're going to see as you're reading through documentation or even creating your own actual networks by designing them from scratch. Okay, as a student of networking, anything else in life, you cannot learn without learning and proving by doing. Okay, I encourage everyone to do and create your own labs. Period. Okay? Period. All right? You can actually go into other books, stuff like that, to see what some of the labs look like. But guys, draw your own. Never, ever, ever have I not created my own labs since day one. Okay? It's given me it's giving me a hell of a lot of confidence when I'm creating video diagrams. I mean, not that you really need that much confidence, but you get the idea. You are writing out every little thing on those diagrams, IP addresses, loopback addresses, drawing the tunnel interfaces or the site-to-site VPN interfaces are a little bit different. They're not just like a straight line. Might be, since it's a tunnel, I like to draw my tunnels with a curve. You see what I'm saying? Things like that. And I like them to be dotted and a little bit darker and definitely a different color on our visual diagrams. You know when you see a tunnel, okay? I like to draw things like this, okay? With, with a nice little hole here. Okay, I'll do that too to create like pipes for VLANs, things like that. Okay, all right, so let's go through some of these symbols. All right, remember, always create your own. Do not be lazy. I don't get it. You're here to learn. I mean, what do you think, it was going to be easy? All right, so now, a router, just a round circle, okay, and the arrows going in and going out is symbolizing and I know my speech is all messed up. Guys, it's just going to take me a while to get back to the swing of things. It's symbolizing that traffic goes in and traffic goes out, okay? And it's going out in a different direction, symbolizing the fact that we are routing. We are sending traffic from one side to the other as far as a network perspective. Because I'm going to teach you this, and don't ever forget it. A router and a switch are exactly the same thing, except a switch, okay, moves things on one level, on one layer, and a router moves things on another layer. We're going to talk about those layers eventually. Now, that means traffic comes in one interface, and a router and a switch has to make a decision. What interface is that traffic that just came in? Where do I send it? What traffic does it get out? Which port do I switch this traffic to? Period. All right, and you can have this debate regardless for hours and hours and hours, but that's exactly what is made. With a switch, we use layer 2 to make the decision. With a router, we use layer 3, but it's the same concept. Traffic comes in. Which interface do I switch that traffic to for it to go out? Period. All right. Cloud. Okay, guys. The term cloud, it's so annoying. Okay. Look. I'm going to take this and I'm going to connect it to this cloud. Okay. Connect it to this firewall. All right. This firewall is connected to the cloud. The cloud symbolizes only one thing and one thing only. We have no idea what's here in this cloud. I know everything from this firewall on the right-hand side of that firewall because it's all mine. I configured it. I put it in place. I had someone design it or I designed it myself. All right? Period. Or I walked in and it was already designed. Doesn't really matter. I know everything is there. I know model numbers. I know passwords. I can configure them. I can make changes. I can log into them, do whatever I want. But the moment that traffic enters on this right side of this firewall, it goes out and hits your internet service provider, or regardless of who is giving you a traffic from that point, you have no idea. It's not yours. You can't log into it, so you don't know how many routers it takes before you get to the other side of that cloud for another site that you have sitting on the other side of that cloud, right? You don't know anything between site 1 and site 2. That's what a cloud is. But we've used this concept of the cloud as if it's like this magical working entity. Okay, guys, let's talk about SaaS for a second. Software as a service. All right. Microsoft 365. Now, they call this a cloud application. Why? Because I pay for service? Or is it because they're using VMware or virtualization? Or is it because why? Someone came up with this term and it just confuses people. The bottom line is it's not a cloud service. Okay? Now, let me give you another idea of a cloud. Okay? Okay, all this is software that they allow you to download and install as a monthly service. Now, okay, Office 365 is one of those things that I will always pay for because one of the hard parts of getting Office is normally it used to be a $400 bundle, okay, for you to get Word and Excel, okay, but then you get PowerPoint and God, what the hell is the name of that damn database? I can't remember. Okay, I think Microsoft Access. Well, I can't remember, but nonetheless, the only 3 softwares that I would use, and I would use PowerPoint a lot, PowerPoint and Word and Excel. The problem was it wasn't worth $400 for me because, first of all, you know, I didn't have money like that, especially when I was just starting off. Okay, when I was starting off, I'm talking about in the 90s. Okay, I didn't have $400 to kick on software. That was a that was a car payment plus insurance plus some of my rent. You know, so that was huge. Okay, not to mention the fact I'm definitely, if I did buy something like that, I definitely would never ever upgrade to a newer version. Not spend that much money for it. But the bottom line is 365 is something that I would pay for every month because I don't have to worry about the new updates, the new versions, the new technology that comes out with it. Okay, but they're providing this as a service, and it stops people from stealing their actual software. Okay, so it makes sense. Okay, but once you call it cloud, let's put these back where they were. Once you call it a cloud service, just the ticks on the back of my neck just start irritating the hell out of me. Now, I'll tell you what is really a cloud service, okay? Storage, all right? Let's say Google Drive, okay? Wow, they give you 10 gigs of free data, but see, what you don't know, okay, is that 10 gigs isn't a physical hard drive sitting there and it's all yours, okay? This would be a definition of a cloud service because what it is they have a box filled with 30 hard drives, okay? All right, each one of those hard drives are 4 terabytes each, all right? Multiply them all together, 120, if I'm doing the math right, 120 terabytes of data, all right? They have software to take those physical disks, combine them as one entity, and share and create virtual hard drives, making your computer believe it is a real hard drive. Now that's a cloud, because you have no idea what's in that, where that hard drive came from. You don't know what it's composed of, how it's built, none of it. Now, if it was actually just a physical hard drive that Google would give you access to, right? It wouldn't be a cloud, because it would just be you logging in and just grabbing a server. Think about this also. You go to an ISP, all right? One of the cool things about ISPs back in the day, which I'm sure they still do, is you get the option of having a physical server that they'll set up in their data center, all right, which won't be their data center. They'll probably use like a Google data center, but it doesn't matter, all right? That server is physical. You can even go to actual Google's data center, okay, with access codes and a badge to get into the actual building, all right, and go to your locker with a key, all right, and physically console in and make changes to that device if that's what you need to be, or it locked up and you need to physically power it down and power it back up. Okay. But if I wanted to provide you a cloud service for that, what I would do personally is create virtual machines or virtual servers. And I will give you 2.5 gigahertz 4-core processor, and I'll give you 10 terabytes of hard drive space for your data because you're uploading a bunch of videos for your website. But none of it's physically real, but it's logically real based on a physical underlay. Let me tell you something. What you see, what you get in that type of environment, I will call that a cloud environment. I will also say that one thing that I'm going to have to teach you and bang into your head, don't ever forget what I'm about to tell you. Underlay and overlay. Guys, there is no virtual without physical. There is none. Okay? You can call it software-defined networking all you want, but that's the overlay concept. The overlay, that what you see is the overlay. It's what is being ran over top of what is real. Your underlay. And your underlay is what physical connections are. Okay? You can't have a wireless connection without it coming back to a physical connection. Okay? Does that make sense? All right? Somehow there has to be something for it to run on. Now, of course, we're talking about radio waves here, right? So like cellular networks, right? They use cellular towers, but once it hits a tower, is it a physical cable that goes back to where the traffic needs to be routed? We don't know, do we? Or do we know? Look it up. Ask. Next time you see a technician out there, right? Yeah, like it's that easy. But you get the idea, okay? All right, if I wanted a wireless hub, a wireless network, I get of the actual wireless device. It's round, it's circle. I used to call it the eye of the house, right? And that was a wireless device, wireless access point. But guess what? It had an Ethernet cable that physically plugged into my switch port. Okay? That's how I got data back to my computers. All right? So I'm not saying you can't build a network without wiring. What I'm saying is there's always an overlay and an underlay, and you got to understand how the cloud term is being used in a fine manner. However, it's been used so much that people just say, oh, it's up in the cloud. Do you know what that means? People don't know what it means. It's just like saying, just like a person saying, oh, well, the economy's bad. Really? Because I took economics, which I didn't, but I took economics, and that statement has nothing to do with what we were talking about. Why would you say that? Oh, because that's the default answer to everything, because that person watches the news all the time. Does that make sense? So take it with a grain of salt, or pick your battles. If you're going to sit there and be on a conference call arguing about what a cloud is, I think you have too much time on your hands. I think it's time to assign you more projects. Does that make sense? All right, so nonetheless, I'm just telling you, though, that's what it means to me. Remember, all this is perception, okay? All of it's perception. It doesn't really matter what you believe in. It doesn't really matter how you perceive something, as long as you're able to adapt and look at a situation and say, yes, sir, yes, ma'am, I could definitely do that for you. I'll fix the problem. Because that's what you're here for, customer service, whether you think so or not. And if you think you're going to be that arrogant jerk that just walks in and doesn't talk to nobody and just says, well, excuse me, man, I think I know what I'm doing. I think I know a little bit more about networking. Yeah, you're a dick. Okay, and that dickish attitude is going to get you to the point where we call it an update. We call it an updating resume event. Is what you call it. Okay, so other symbols, a hub. Look at the hub, though. Okay, first of all, the hub has just one straight line all the way across. What it's telling you is, with that symbol, is the fact that whatever goes into port 1 gets shared over port 2, 3, 4, 5, 6, all those ports, okay, will get the information. Whether it's supposed to or not, doesn't mean it'll take it. Okay, if it's not meant for itself, it'll drop it. But the point is, everyone gets it. Everyone can read it. I can literally just put a sniffer in there and just read everybody's data. The switch. Interesting, right? Switch is always kind of interesting. I guess someone was like, I don't really know how to draw this symbol, and I can understand what they're trying to draw. What they're trying to draw is something's coming in on one port, but it's only going out a specific port, okay? And it's only going out the port that it is destined to go to. All right, we are switching that information. We're not switching anything in a hub. We're sharing it. All right, we're just throwing the bowling ball, or I should say, throwing the cards across the table as they slide across the table. Right, that's what we're doing. Everyone gets cards. All right, done. All right, but with a switch, no. You get nothing because your name is in Tom, and this card is for Tom and Tom only. So we're going to switch that information. All right, coming from my port. All right. And thank you for Tom's card. Let me switch it out to Tom's port. All right. Okay. Bus. Remember we talked about the coax cable? Yeah, that's pretty much what the bus is. Okay. You got serial connections, which I doubt if you're going to see anymore. And you got Ethernet connections, which you're going to see a lot of. And fiber connections are usually just straight lines. Okay. All right. Firewalls, pretty much, like I said, they're checkpoints. Right. You're driving down the street, 2 o'clock in the morning. And next thing you know, you see flashing lights and a row of cars. That firewall or that officer tells you whether you're permitted to go past or denied to go past. All right? That's why you have data coming in as an arrow, okay, and then bam, a wall you've hit. Okay, and you're not getting past that wall unless you are allowed, specifically allowed, okay? By default, firewalls allow 0 traffic. The only way you're getting through is if I make a statement saying this particular traffic is allowed to come through. Come on. All right? Default, all traffic is denied. Router, all traffic is permitted because we want to build those roads. We don't want to have that hindrance. Can I turn a router into a firewall? Of course I can. All right, zone-based firewalls if I want to do that way. However, the bottom line is I want to allow all traffic with a router. I want that traffic to get from point A to point B because that is the purpose of the router. Not to stop traffic, but to allow it, to move it, to route it. Okay? Bridges. All right, best way I can spin a bridge. Think of a bridge as it looks like, literally a physical bridge that you ride across to connect two pieces of land. Think of each one of those pieces of land that you are bridging together, okay, with your bridge are interfaces. So port 1 and port 2, they're routed ports, okay? One thing about a router is you can't have two interfaces on the same network. That would defeat the purpose of a router, considering the fact that the purpose of a router is to allow communication between networks, okay? Two things I'm going to say. One, everything that I teach you, there is a caveat. There is a way to break that rule, okay? So I'm going to show you one of these days how to break that rule, but at the same time, TCP/IP's protocol by default will not communicate with another network without having a router in between them. Okay? Now, but what if I wanted two interfaces to be on the same network? That means whatever comes in on interface A or network A, I want interface B, okay, on network B, did I say that right? To actually get that information. Bridge those interfaces together. That means whatever comes in on interface A, okay, B is going to get it. That means I can have two interfaces bridged together, just like you twisting a tie, right? A zip tie or what the hell ever, a twisty tie for bread, all right? And you bonded them together. So that means I can have people on network A on this side, on this interface, and people on network B on this side. That's breaking the rule, okay? That's one way of doing it, okay? And that's the whole purpose of a router, or that's the whole purpose of a bridge. We could do this physically, or we could do this logically. Now, physically, okay, let's say we have two networks, right? And we want to bridge those networks together. So we take both networks and start plugging cables in. Network 1 and network 2, right? What I'm going to do now is I'm not going to separate the networks logically from a TCP/IP perspective. I'm going to make those changes by taking network 1 and network 2 and put them on the same network and use a bridge, all right, to logically bridge these networks together. Therefore, all the MAC addresses on network A, all the MAC addresses on network B, whenever anyone needs to send traffic over to network A from B, the bridge will bridge that gap. It says, oh, that MAC address is on network A side. Let's send it over there. You just bridge them together. Okay? All right, and that's all it is. These terms, they get confusing, but at the same time, hey, we're going to get through it. So, how does it all fit? Well, guess what, ladies and gentlemen? You live in okay? And you decide that people on your floor are your buddies. And you're going to network them together, and you're going to play StarCraft. All right? Who cares why you did it? You got them all together. Everyone on floor A is actually, I don't know why I keep saying A and B, but first floor, all network together, and these are your friends. Now, someone on the second floor has done the exact same thing. Okay? So, here is floor 1, here's floor 2. Doesn't really matter. I don't care if it's interchangeable. And somehow you two end up finding each other. Oh my God, you did the exact same thing I did. Wow, hey, what if we all got together? All of us got together, okay, and partied together. That's fantastic. But I'm not changing my network. Well, I'm not changing my network either. You know what we could do? Everybody on my network, if I put a switch there, everybody can plug into my switch, and we all can communicate with each other without needing anything else. However, you're on a different network. So instead of going through redesigning all these IP addresses and doing all that stuff, that's a lot of work. Why don't we just use a router and put between the switches? Okay, that means this interface here. All right, hold on. let me go back over here. Boom. Do my horrible drawing. I think I could just. This interface is on network B. This interface is on network A. And the router is going to say, and it's going to literally have a route. It says, hey, anything that's going to network A, sending out this interface. Let's say this is interface 1, and this is interface 2. All right? Yeah. Guys, I really wish I had my pen, but, I don't have one. So, nonetheless, anything that's coming in on interface 1 that wants to go to network B, let me rephrase that. Anything coming on interface 1 from network A, which is going to be from network A because that's my interface is in network A. It's configured for network A to communicate on the same IP address. Anything that comes in on interface, if it has to go to network B, on network B's network, I'm going to send it out interface 2. What did I tell you? It's nothing but a switch. That's all a router is. Packet came in, which interface does it go out on? Okay? Now, this is how it fits. This is what you're going to be doing. You're going to be learning how to configure routers and switches. That's your bread and butter. If this is what you want to learn as far as a network perspective of a CCNA and a routing and switching perspective, this is what we're going to learn. Okay? We're going to get to ASAs and stuff like that, but that's going to be later on. And it won't be a CCNA topic, but it might be. Again, remember, I'm not teaching you to pass no damn exam. Screw that exam. All right, you can do that on your own time. I'm teaching you from a network guy's perspective and how we do the things that we do. And one of the things you're going to learn and have a perspective of is how much knowledge is out there and what being a network engineer really is and all about. Okay? All right, guys, as always, be strong, be determined, and be Cisco.